4, that is arithmetic operations. Okay, so here it is arithmetic operations. You know that in ALU, arithmetic logic unit, the operations takes place. This arithmetic operations takes place. Okay, so you will also know that this ALU consists of many circuits. Okay, it contains many circuits, that is all the logic gates, that is using NOT and or using all these gates. Okay, this logical circuit is built so that these operations, that is arithmetic operations, can be performed. Okay, now we will see initially how these operations are performed, the signed numbers, okay, how it is represented, how the addition, subtraction operations takes place, how is the circuit in the within the ALU for doing these operations. Okay. So that is the content of this module. So you know that anything in computer is represented in binary. Okay, whether it can be a character or a string or any numbers. Okay, any instructions. So all this are represented images. Okay, all these are represented in binary, that is zeros and ones. Okay, so zeros and ones are used for representing the or storing any data in system. Okay, now suppose it is a signed integer, that is there is negative numbers involved. Okay, if it is a signed integer, what are the different ways in which data can be stored in a computer? So there are 3 different ways: using sign and magnitude, using 1's complement and 2's complement. Okay. So as I told, all of you are know it is the data information is stored in binary form. So we'll see the numbers, because only for numbers the sign comes into picture. Okay. The sign, that is positive or negative. So everything else, that is it can be character or the string of characters. Okay. So all those things are represented by bits. So it is a string of zeros and ones to represent this characters or instructions, whatever images. It is just a string of instructions, string of bits. Okay. So there the problem of sign doesn't come. But now suppose you know that 2 is represented like this. I want to represent -2. Okay. So it is a different way in which it must be presented. Correct? So what are the different ways in which the signed integers can be represented? There's 3 ways, that is sign and magnitude, 1's complement and 2's complement. What is the sign and magnitude system? So in sign and magnitude system, the magnitude part, that is how the value is represented. Okay. Now 2, I am representing like this. Okay, 0, 0, 1, 0 is 2. And in sign and magnitude system, if I want to represent -2, okay, I store this magnitude value, and the most significant bit is stored as 1. Okay, so in sign and magnitude, the MSB, or I can say in all these methods, the MSB indicates the sign of the particular number. Okay, MSB indicates the sign of the number. Now minus, now I have stored 1 here. So 1 means it is a negative value. And this, the remaining bits, indicates the magnitude of that particular digit, what I have stored. Okay, so this is sign and magnitude system. This is the positive value and negative. It retains this value, and most significant bit is changed to 1. Okay. Now, in one's complement, how it is represented? One's complement in this particular technique, how it is represented is, suppose 2, I want to represent the magnitude, the positive number is stored in the same way in all three techniques. 2 is this itself, okay? Minus 2, how it is represented? What is one's complement of this particular series? What is the one's complement of this? Is complement of these bits. Okay, complement of these bits such that when you add this one's complement and these bits, okay, you get the highest digit. Okay, so what is one's complement of this is reverse of this bits you can take. So binary digits consist of 1 and 0. Okay, so reverse of this bits is one's complement, that is 11101 is one's complement of plus 2. Okay, that means minus 2 is represented by 11101. Okay, so this is one's complement system of representing the signed integers. Okay, now suppose I want to store 5. Okay, I want to store 5 in one's complement system. So what is the binary digit 5? Observe this. I'm using 5 bits to represent all the numbers. Okay, so until mentioned in the exam also, use 5 bits. Okay, you can use 8 bits also, but it becomes more. The number of bits becomes more and it is time consuming. So always you can use 5 bits. Okay, if the numbers are very small, fine. How is plus 5 represented? What is plus 5 in binary form? Binary form of plus 5?
0101.
Okay, so 0101, 5 bits I told. So I have put a 0 here. Fine. So one's complement of it, that is minus 5, is the reverse of this bits. Okay, that is complement of this bits. So 0 instead of 0, it is 1. Instead of 0, it is 1. And 0, 1, 0. This is minus 5 in one's complement system. Okay, so you have seen two systems of representation which can be used in a computer. Okay, so that is sign and magnitude. In sign and magnitude, to represent negative numbers, I retain this magnitude part and most significant bit is set to 1. Okay, in one's complement system, the values, the bits are reversed. The complement of the bits are taken. Okay. Now coming to 2's complement. I think that all of you know how to find the 2's complement. 2's complement of a bit pattern. Suppose I take plus 2 is 00010, correct? So 2's complement of it, how do you find the 2's complement? The procedure to find the 2's complement is find the 1's complement. Okay, find 1's complement and add plus 1 to it. Add plus 1. So that gives the 2's complement of any binary string. Okay, so plus 2 is 00010. I am taking a 5-bit pattern. Okay, so 2's complement of this. What is the 2's complement? I'll first find the 1's complement, that is okay. So I'll first find the 1's complement. 1's complement is 11101. Okay, I have to add plus 1. which gives you the 2's complement. Okay, this gives the 2's complement. So that are the three ways. We'll see the addition later. So that is the three ways in which the signed numbers can be represented. Okay. Now, which is preferred? Which is preferred in the system, which is used in the computers, is 2's complement. Can anyone tell why 2's complement is preferred? 2's complement system is used in the computer. Can anyone tell me why 2's complement is preferred? Okay, just observe this and tell me. So 1's complement, if I am using 1's complement, suppose. Okay, how is 0 represented in 1's complement? 0 is the same, correct? Okay, this is plus 0. Suppose there is minus 0. I want to find the 1's complement of it. Can you find 1's complement of it? It is 1. Okay, 1, 1, 1. So this represent minus 0. So that means in 1's complement, there is plus 0, that is positive 0, and negative 0. Okay, which is not real, which is not ideal. Okay. In case of sign and magnitude also. So if this is 0, in sign and magnitude, if I represent like this is minus 0. Okay, in 4-bit, 4-digit binary value. This is minus 0. So there is plus 0 and minus 0 in both sign and magnitude and 1's complement. Whereas in 2's complement, there is only positive 0. Okay, so we'll try this. There is only positive 0. So this is 0, and 2's complement, if I check, okay, 1's complement plus 1, you get this. You get zeros only. Okay, the last bit is discarded actually during addition. We'll see that later. Okay, so you get zeros only. So you don't have 2 zeros. There is only positive 0. Okay, and hence 2's complement is preferred, is used in systems. Okay, you can, it is these circuits are easier to build. Okay, whereas sign and magnitude or 1's complement can also be used in the system, but circuit building will be little tough. Means the more number of gates has to be used for that circuit building. Okay, hence 2's complement is used. Now, how do you add two numbers? You have to convert the numbers to binary. Okay, and if it is a negative number, find the 2's complement of it, and then add from right to left. Okay, so we'll see how to find the 2's complement and come to subtraction later. So just we'll see the addition rule. Okay. I think all of you know those rules of addition. 0, 0 is 0, 0, 1 is 1, 1, 0, again 1. So 1 plus 1. 1 plus 1 is 2. Correct? So 2 is nothing but 1, 0 in binary. So 1, 0 means 0 is the value and 1 is carried. 1 is carried. Okay. So if I have 9 plus 1, okay, that is 10. So you put 0 and 1 is carried, correct? Similarly, in binary, I can represent 1 plus 1 is 2. 2 I can represent as 1, 0. Okay, so 0 is the value and 1 is sent to carry bit. Okay, and if it is 1 plus 1 plus 1, the value is 3. 3 is nothing but 1 and 1. Okay, so 1 is the sum and 1 is set to carry bit. So this is the rules of addition. We'll just see an example. of this additions. If I have this addition, suppose, okay, 1 plus 1, how much is 1 plus 1? Is 2. 2 means 1, 0. Okay, so 0 that is in ones place or units place, I use that 0 here. Okay, and which is in the next higher position, 1 is carried. That is what you do always, correct? So when I am adding a single bit, the units place bit is stored here, and one is the other bit is carried top. Again, 1 plus 1 is 0, and 1 is carried. Okay, so 1 plus 0 is 1. 1 plus 1 is 2. Again, 2 is this. So 0 and 1. Okay, so this is the how you do the addition of two positive numbers. If it is two positive numbers given directly, we'll see more in detail next. So this also is positive numbers. Just observe this, the addition process. Okay, so 9 is all of you must be sure with at least till 16. You must be sure. Okay, means without finding it out itself, means you must know this by default. Okay, without finding, like I think all of you know how to find the binary pattern of 7 decimal value, how to represent in binary 7. So 2, you divide by 2 times, 2 3s are 6, 1 is the remainder, and 2 1s are 2, 1 is the remainder. So this is the value, binary value of 7. That is 1 1 1, followed means it is previously any number of zeros. How many of our bits the number, how many of bits it should represent, that many zeros you can add. Okay, all of you know this conversion from decimal to binary? Yes or no? All of you are having book with you right now? Am I audible?
Yes, ma'am.
All of you are having book with you?
Yes, ma'am.
Others?
Yes, ma'am.
Okay, now find the binary value of 23. Binary value of 23. And tell me, what is binary 23?
Ma'am, 10111.
10111. All have got the same?
Yes,
All have got the same. This is to the base 2, correct? Now, how do you convert into decimal? I'll just tell you how to convert into decimal. Suppose I have a binary pattern like this, okay? And I want to find what is the decimal value of it. So many of you will be knowing, just observe this. So this units place 1 is to the power of 2, 2 power 0, and this is 2 power 1, 2 power 2, 2 power 3, and 2 power 4. Okay, so it is 1 into 2 power 4 plus 0 into 2 power 3, it is 0 here, okay, plus 1 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0, okay, that is 2 power 4 is, how much is 2 power 4? How much is 2 power 4?
16.
16. 16 plus 2 power 3. So 0 into 2 power 3. This is just 0. Correct? So plus 1 into 2 power 2. What is 2 power 2? 1 into 2 power 2 is What is 2 power 2?
4.
Is 4. Plus 2 power 1. 1 into 2 power 1 is
2.
2 plus 2 power 0. 1 into 2 power 0. 2 power 0 is 1. Okay. So anything to the power of 0 is 1. Fine. So 1 into 1 is 1. Okay. Now do the summation of this. How much do you get? 16 plus 4 is 20. 20 plus 2, 22 plus 1 is 23. Okay. So it is 23 to the base 10 means decimal value. Correct. So if you have a decimal value, you have seen how to convert into binary by doing the division. And if you have a binary number, it can be converted to decimal by using this method. All of you note down this procedure. Okay. Now find 127, the binary value of 127. Binary value of 127. Who will find first? Let me see. Binary value of 127.
One 11011.
1 second.
7 1 8 1 7 1.
I have told the binary of 127. Okay, binary of 127.
Oh, 7 ones, ma'am, because it raised to the power 7.
Okay.
To the power 8 minus
7
1.
months. Yes. 7 months. Okay. Yeah. So the answer is random very number. Binary of 127 is 1 1 1 1 1 1 and 1. Okay, I'll give some other number. I want answer from someone, any other person. Find binary value of 55. 55.
One 11011, ma'am.
Yes. Just 11011. Okay, is the binary value of 55. Okay, and also note that if suppose in the exam or suppose any time you want to represent it in 10 digit. Okay, now this is 6 digit. If I want to represent in 10 digit, you have to add zeros here. Okay, so it is 10 digit representation of the decimal, the 10 digit representation of this 55 in binary form. Okay, any doubt? Okay, in this chapter you must also know how to convert the binary value into decimal. Okay, I'm sure all of you know by now how to convert. We had just seen it, how to convert this binary digit to decimal form. That is, you take 2 power 0, okay, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. Find these values you will get the decimal value of it. Okay, so 1 into 2 power 5 plus 1 into 2 power 4 and so on. So solve this expression, you will get the decimal value from this binary bit pattern. Any doubt here, students? Any doubt? Okay. So if there is no doubt, we will just proceed with the problems. Okay. Yes, these problems will come for exams. Okay. Just add or subtract two numbers. Okay. In many of the question papers which you take, you can see that this types of problems have come. Okay. Directly numerals will be given, and you have to find the summation or solve this particular operation. Okay, now 9 is represented like this. I have taken the 5 bits. Okay, and 5 is 101. Okay, now I do the addition. So I think all of you know how the addition should be done. So for addition, 1 plus 1, all of you observe, 1 plus 1 is 2. 2 is nothing but 1 and 0. Okay. So as there are more number of digits, I stored whatever value is there in units place in this under this 1 plus 1. And in the next position, next higher position, value is sent as a carry to the next higher position. Okay, so 1 plus 0 is 1. Again, 0 plus 1 is 1, and 1 and 0 is 1. Okay, this is 0. So a positive number, MSB is 0. So it is a positive number, and the value is 110. So by seeing itself, you can know what is 110. If you don't know what is 110, then again do this process to find what is the magnitude in decimal form. Okay, you have to write it in the decimal form. You can also cross check whether the bit pattern, this is a small number, so no problem, you will know. If the bit pattern is correct, by converting into decimal form, you will know, because this answer, you know, it is 14, correct? So whatever bit pattern you have got is correct or wrong, you can check like this. Okay, so it is 2 power 3, 1 into 2 power 3 is 8, plus 1 into 2 power 2 is 4, plus 1 into 2 power 1 is 2, plus 0, that is 14. Okay, it is 14. So when it is a positive number, there is no problem. It is just direct addition. Okay, now when it is a negative number, suppose it is 9 minus 5, I can write 9 as usual. Okay, when it is negative number, minus 5, you have to find its complement, 2's complement of minus 5, and then add. Okay, so 9 plus minus 5. I have to find the 2's complement of this and then add with 9. Fine. So yes, here 9 plus minus 5. So 9 is this, minus 5. What is minus 5? I have to find the 2's complement. So 2's complement is, this is 5, and 1's complement of it is reversing of bits. Okay, plus 1, do the addition here. So you got this, this is minus 5. Okay, so throughout this chapter, you should remember that any number with minus, okay, any number having minus must be converted to its complement, 2's complement. Okay, and also if from minus 5, I want to know, I have got a bit pattern. Okay, this is the bit pattern what I have got, but I don't know what is the value here. I don't understand. Now, this is the answer, suppose you have got after some operation. I did minus 19 plus 14. Okay, I get minus 5. I get this answer. Somehow I get this answer. Now I want to find what is the value which is stored here. How do I find the value? I should again find the 2's complement of this. Okay, to find the 2's complement of this, when I find the 2's complement of this, I get minus of minus 5. So that is plus 5. I get the value what is stored there. Okay, the sign retains. I know that it is a negative value because most significant bit is 1. Most significant bit is 1. Okay, the bit pattern what I have got from the answer is this, from this particular operation. Suppose I have got the bit pattern as this, that is 11011. Okay, I want to find what is the value of this. Observe that most significant bit value is 1, so the result is minus. The answer what you have got is minus. Okay, now find the 2's complement of it. By finding the 2's complement, you get 0, 0, first 1's complement. So 0, 0, 1, 0, 0, plus 1, you get 1, 0, 1, 0, 0, that is 5. So you know that after this operation, whatever bit pattern you have got, it stands for minus 5. Minus because most significant bit is 1. Okay. So what I'm trying to tell is, if you have got a value, you want to find the complement of this. Okay, you want to find the negative value of it. That is, I want to find the negative value of minus 5. That is plus 5. Okay, so you can do 2's complement. Fine. Okay, coming back to this, minus 5, I do this 2's complement, I get the operand value, second operand value. Okay, so minus 5 is this, it is taken to top. Okay, do the addition process. Yeah, do the addition process. When I do the addition process, 1 plus 1 is 0, 1. So 0, 1, and 1. 1 plus 1 is 0, 1. Okay, 1 plus 1 again 0 and 1. Whatever you get more than the number of bits of the operand, so this part is discarded, is not considered. Okay, that is, the operands I have taken, what is the size of the operands? It is 5 bits. Correct? It is 5 bits. So the answer should also be of 5 bits. Whatever extra bit you get is called as a carry bit, and it is discarded. Okay? Got? Fine. Okay, so what I have written. Yes, okay, so it is 0, so that means the answer is positive value and the value is 4. Okay, so it is plus 4, MSB is 0. Okay, whatever extra bit you get is discarded. Fine. So that's enough for today. You can just note down these few problems. Yeah, this is one of the problem which has come in previous question paper. See, it is mentioned here 5-bit sign numbers. 5-bit sign numbers andre you must convert this into 5 bits only. Okay, and then after addition discard the carry bit. If nothing is mentioned, you can take how much ever the maximum, like 7-bit, 7 value 7 I want 3 bits, and value 9 I want 4 bits. Okay, so you can, including the sign bit, include the sign bit always. It is so minus, so whatever I take the sign bit, Okay, you can take one more bit also. However, what I'm telling us, this many bits must be taken. Okay, compulsory, that is 5 bits, including the sign bit that must be taken. Now this is +9, it has to be converted to -9 for doing this operation. Okay, now, yes, all of you do 2 plus 3. Okay, and +7 minus 3 in your book. +2 plus 3. Okay, that is addition of those two numbers, and +7 minus 3 in your book. Okay, whatever I am telling, follow the instructions. Okay, follow this, copy down this question, these two questions, and solve it in your book. Before you come to the next class, you should have solved this in your books. Okay, so be regular to the classes. Don't miss any class, because this module is easy and you can understand everything only if you attend. Okay, so any doubts?